Hello. This video will demonstrate how we can find instantaneous velocity using the concept of limit. We saw in a previous lesson that to find instantaneous velocity, or to estimate it, we can find the slope, we can estimate the slope of a tangent at a particular point. And that worked very well. Now we're going to calculate it using the concept of limit. All right. I will show you both methods so this formula makes sense. Okay. So the formula says, okay, at some time t, all right, what I'm going to do as h approaches 0, I would like to find out what the limit of this entire function is. All right. Best thing to do is let's look at an example. So I have this function of t, a function of time, 2t squared minus 3, and I would like to find the instantaneous velocity at t equals 1 second, most likely. Okay? All right, and I've written down my formula. Yes, you will have to remember that formula. So when t equals 1, all right, I'm just going to focus on this piece right now. All right, so I'm trying to find the function of 1 plus h minus f of 1. And where am I getting the 1? I want to find the instantaneous velocity at t equals 1. If I wanted to find at t equals 4, then I would put 4 here, okay? All right. So 1 plus h is my input here. So be very careful about that. All right, this is my input into our function. Minus, all right, what's f of 1? All right, 2 times 1 squared minus 3. All right, all of that divide by h. Okay, again, as I said, you really need to know your algebra. I'm going to expand this. Right, 1 plus h quantity squared is 1 plus 2h plus h squared minus 3. All right. 1 squared times 2 is 2. 2 minus 3 is negative 1. All right, what I'm going to do, just to save space, that's all right. I'll just put it all over h. That's fine. All right, and now I'm going to sort of, simplify this, use the distributive property. I have 2 plus 4h plus 2h squared. Hoping you're agreeing this is plus 1. Right? Plus 1 over h. So far, so good. Okay, again, if you're wondering what I did here, 2 plus 4h plus 2h squared. Oops, I forgot my minus 3. That's not good. So let's just, so again, a good lesson. Always check your work and make sure that you know what's going on here. Okay, now, so there's my minus 3. And then, yes, subtract a negative 1 is plus 1. All right, okay, so we're going to continue to simplify. I have 2h squared plus 4h. 2 plus 1 is 3. 3 minus 3 is 0. Well, okay, so I guess it cancels. That's a nice thing. All right. I've got a bunch of h's, right? So let's factor out an h on the top. Let's factor out a 2h, right? I can factor out 2h. So I have h plus 2. All right, or we could have just factored in h, it's fine. Okay, I can see that I can cancel these h's, no problem. So what this ultimately becomes, don't forget we're ultimately trying to find a limit, right? All right, let's go back to that. As h approaches 0, what is the limit of 2 times h plus 2? Again, this is a polynomial. This is a constant. Both limits exist when I put 2 in here. the limit will be 4. So what this says is, at time equals 1 second, my instantaneous velocity, again, let's assume we're dealing with meters per second, is 4 meters per second. All right. So again, it's not a crazy concept. All right, take that back. It's not a crazy. Formula. It's just algebra, right? You got to know how to expand, distribute, and of course, don't forget little pieces, right? So if you get something wrong. And the reason I wanted to draw it for you is that we can actually see. I said that in an earlier chapter we saw that instantaneous velocity, we could estimate it by looking at the slope of the tangent at, in this case, t equals 1. And I can see, right, if I look at this, let's be a little thoughtful about this. Okay, let's make it green, right? If I look at this, all right, I'm going up. Let's try that again. Looks like I'm going up 4, right? But I'm starting here, and I'm going over 1. So this graph is, again, remember, a graph is not as accurate as this, but it gives us an idea, and it does make sense that from the graph we have an instantaneous velocity of 4 meters per second. All right. Now let's look at this function here and see how it relates to what we did in an earlier chapter. So as you can see, right, using what we saw in a previous lesson, 3 steps. You get 1 point. They're going to tell you at t equals 1. You're going to choose an x value very, very, very close to the x value they give you. You're going to find the corresponding y. You're going to find slope. So I want you to see how this relates to this formula here. Right? I hope you would agree that this is going to be, right, the difference between that is, right, in this case that's negative, correct? All right, well, that's our h, right? The difference between this and this, again, is 0.0001. That's our h. So we're saying as the difference approaches 0, as I get really, really, really close to 1, by choosing numbers, by choosing x values very close to 1, I could go 1.00000000000000001, right? So I'm approaching 0. This really is our slope. What's the difference between the y's, right? Change in y divided by change in x. How did I change my x value? By some variable we're going to call h. All right. My point is, this formula uses limits. It's going to be much more accurate because we know how to calculate and compute limits now. This is what we did to estimate the slope. Obviously, this is an estimate, 4.01. In our previous screen, we were able to see that it's 4 meters per second exactly. All right, so limits are very powerful in this context. All right, let's look at another example. So I can see here my function of time is t cubed minus 1. Again, you're most likely not going to get the graph, but again, you know that I like you to see what the graph looks like, and the slope of the tangent at t equals 1 second, you can see it looks to be about 3, correct? So we're going to hopefully see something close to 3. So again, let's plug this in. I'm just going to deal with this first. Again, I'm using t equals 1. T can be obviously positive, but it can be anything. Okay? So 1 plus h cubed minus 1. All right? minus, right? What's when t is 1, what's this value, right? 1 cubed minus 1, well, that's 0, right? Okay, divide by h, all right? And I know what this is going to be, and hopefully you know what that's going to be, using the binomial theorem. All right, and this time I'm not going to forget my minus 1 here. Minus 0, so that's that. Okay, and you're noticing something here. 1 minus 1 is 0, so that kind of goes away. I'm going to factor out an h, so I have 3 plus 3h plus h squared. I can see, and again, you'll see patterns as you practice this. The h's cancel. Let's go back to what we're ultimately trying to do. We're ultimately trying to find out what is the limit of that function, right, as h approaches 0. Okay, 3 plus 3h plus h squared is a polynomial, so it's continuous. So all I need to do is find out f of h, f of 0. All right, the limit of a constant is 3. What was that? Right? As h approaches 0, this is going to be 0. As h approaches 0, this is going to be 0. So again, the graph matches what we see. Excuse me, what we see from our calculations. Okay? So the basic thing is the most important thing is you have to remember this formula. In the grand scheme of things, I suppose, you could go back to what we learned in an earlier lesson. Get 2 points, calculate slope, and get really, really close so your estimate is close. But trust me, you will see this formula again and again and again, so you have to know this formula. Okay, so as h approaches 0, what is the limit of this function? Well, I hope that helps. Thanks for watching.